Oh, wait, let's get into this. We are doing a deep dive today on, well, what's basically the circulatory system for professional broadcast audio.
Right.
It's the Thor Broadcast F-2A-XLR-PHP-TXRX fiber optic converter kit.
That's a mouthful.
It is, but what it does is it takes two channels of high-quality analog XLR audio and just pushes them over incredible distances using fiber.
And our mission here is really to pick apart how it manages to maintain that, absolutely pristine broadcast quality.
Yeah, stability, right?
The stability. When you're engineering a live event, a massive remote broadcast, consistency is everything. It's non-negotiable.
We're talking about killing noise completely.
And guaranteeing that reliability over runs that can go up to, 20 kilometers. It's huge.
So I noticed something right away in the model name, that little acronym, PHP, Phantom Power.
Mm-hmm.
This unit supports 48 VV-DC phantom power, and it's switchable for each channel. Why is building that right into the transmission unit such a big deal for engineers in the field?
Well, it solves an immediate, very practical problem. Your high-end condenser microphones, they need that 48 volts to operate.
Okay.
By building it directly into the transmitter, you're eliminating extra gear. No more outboard power supplies.
So less complexity, faster setup.
Exactly. And the really clever part, the engineering detail, is that they include an automatic high-pass filter.
And what does that do?
It's designed specifically to isolate that DC power offset. So it guarantees the power signal never bleeds into your audio path. It keeps it clean.
That kind of precision makes sense, especially when you're going from analog to light. And that's where the core tech comes in, I assume. It uses an FPGA?
A field programmable gate array, yeah. Along with really solid clock recovery technology.
And why does that matter to, someone using this?
Because an FPGA means the system isn't locked into some rigid proprietary hardware. It gives you flexibility. You can do firmware updates, customize it.
So it's future-proofing the investment.
It really is. And if you connect that to the quality, they're using an intelligent noise reduction system to get a signal-to-noise ratio, an SNR, of 100 dB.
Okay, for our listeners, what does 100 dB SNR? What does that actually sound like?
It sounds like nothing. It means the noise floor is, for all intents and purposes, non-existent.
Just absolute silence.
Just silence. It lets the full dynamic range of your audio come through perfectly clean. Plus, this system is smart enough to handle, say, soft power-ups or downs.
Without that awful pop you sometimes get.
Without the pop. It handles simulated squelch and ramp waves without any of those audible artifacts that plague less robust systems.
So these are basically studio-quality specs in a field device.
Yeah.
We're talking 24-bit audio sampling, 192 kHz sampling frequency.
Yeah.
That's a huge dynamic bandwidth.
101 dB. The fidelity is absolutely there.
Let me push back on the range, though. 20 kilometers. That feels like overkill for most stadium or campus jobs. Are we paying for distance we might never actually use?
I see what you're saying, but that 20K standard gives you peace of mind. You never have to worry. But the real value is that the same engineering that gets you 20 kilometers.
Gives you rock-solid stability at 2 kilometers.
Precisely. And for field use, this is critical. It has level 3 lightning protection built into the audio interface.
So if a storm rolls in and you have cable running across a field...
That's your insurance policy. It keeps your very expensive, very sensitive interfaces from getting fried.
Okay, moving to the practical side. It's plug and play, which is great, saves time. But the real scalability seems to come from its modular design.
It is. This kit uses CWDM technology.
Coarse wavelength division multiplexing.
And that is the future-proofing element we talked about. CWDM lets you stack multiple signals onto that one single fiber link.
So you start with 2 channels of audio.
And you can expand it to carry video, data, network traffic, phone lines, you name it, all at the same time on one fiber.
That totally changes how you design the infrastructure for a big venue, doesn't it?
Absolutely. You just drastically cut down on the physical cable you need to run. The hardware supports it too. Plug-and-pull card design. It's ready for a 4U rack.
And it has different optical ports, SFP and so on, to connect to whatever's already there.
Right. It makes integration much easier.
And finally, the durability. A working life rated for over 100,000 hours. This is built for serious, relentless commercial work.
No question.
So the big takeaway here is that this is high-fidelity, super reliable gear for covering huge distances while still powering your most sensitive mics.
That's it. It's really a foundation for a whole unified communication system. And that brings up a final question for you to think about.
One.
If one single fiber link can reliably carry not just your 192 kHz 24-bit audio over 20 kilometers, but because of that CWDM capability, it can also carry your video, your data, your network traffic all at the same time. How fundamentally does that simplify the entire engineering backbone for a major live event or even a distributed broadcast center?